to Air-Cooled Anything. Today I'm going to be working on my CB Performance 2017 cc motor, which was bought as a kit from CB as part of their, what do they call them again? Engine Builder's Choice Kits. So I bought the whole kit and caboodle from them, everything is supposed to just bolt together. And I'm working on the camshaft today, putting in the bearings, looking at all the tolerances to do and clearances to do with the camshaft. Next thing I'm going to do is install the camshaft bearings. I've already opened the packet up, given them a really thorough clean. They're in pairs, 3 different types. There's a flanged type, goes by where the gear goes. Oh, and also, yeah, forgot to mention, they've got like a tang on them, or a tab, some people call them. And the tabs match up with the tab holes in the engine case. There's no tab holes here on this case. So where the hell does that tab go then? I've been inside and done a whole bunch of Googling about these cam bearings, and there's a lot of debate. Half the people online on the forums are saying you file off the tang on one of the bearing halves and then just fit it to the case. Easy. And the other half are saying create a tab in the case, so file the case so that it accepts the tab. So I didn't know what to do, so I contacted my friend Steph, who runs Air-Cooled Engineering, Ace Engines in California. He's the main man there. Well, I think it's just him actually, isn't it? He makes race engines and like extreme street engines. He's been doing this for years here in the UK. He's just moved out to the US a couple of years ago and he's doing brilliantly well over there. So I text him, asked him what he does, and he's like, nah, just file this. He said it's just for locating purposes. You're not going to get the bearings are not going to spin round, and you just file it off. So that's what I'm going to do. Very, very carefully. Got a flat file, and I'm going to file it by hand. I don't want to do it in the vise. If I do it in the vise, I'm worried if I put it in the vise like this, I'm worried I'm going to distort it by crushing it, so I'm going to very carefully do it by hand. There's got to be a smarter way of doing it than this. I'm obviously worried if I leave too much of the tab on the back, then it's going to force up this edge of the bearing and make a tight spot. And if I take too much off, I suppose it potentially could make a loose spot. Better a loose spot than a tight spot though. So I've just cleaned up that top edge as well, just a very gentle wipe, just because it was a little bit sharp from burrs from the filing. There we go, no tab. Obviously the material here, where the tab was pressed in, is very thin, but not so thin as you'd be worried that bits could break off. I reckon it's a mil thick, maybe 0.75 of a mil. So thin, but not like sharp thin. On this side of the case, the tabs are down. On the other side, they're up. So where the tab was, I'm going to put it there. It just presses in. Never push them from here, always push them from the edges. Very slightly raised on these edges. Just press the others in now. The wider one goes in the middle, and the narrow one goes at the back near the flywheel. I'll do the other side and then we'll test fit the cam. So here's the camshaft. I'm just going to plop it in and see how, oh, before I do that obviously, it's got some oil in there. What I've learned from doing this is I've cleaned the case up, but we're going to have to assemble it and disassemble it a few times, test fits, and just make sure. Now, I thought this might happen. So what's happening is the cam on this bearing surface is not dropping down. See the way on this side, it's just, it's so tight, it's stuck on there. It just drops into these bearings nicely, and then when you tighten the case down, it grips it up. But on this one, it's just not fitting. And I've read a little bit about this. See, another thing we're learning as we go along. So if I get the bearing out, is the thrust surfaces here are rubbing, oh sorry, got it now, are rubbing on the flanges on the cam. So apparently what we do is we just sand these down a little bit, and obviously there is a bearing surface on there, and we don't want to go too much because we don't want the cam slopping backwards and forwards, and we don't want to go too little so it excessively wears. Yeah, you see I'm trying to offer that up. I don't want to force it on, but it's just not going on. I guess this is all part of the joy of working with modified engines. All the stock stuff I've done before, things just kind of bolt together and it works. So no warnings on any of these kits about any of this sort of stuff. We'll supply the bits, but then you have to modify them all to work. You've got to be quite confident, and you've got to know sort of what you're doing and be willing to do the research. I don't know what I'm doing. But I'm confident, so I'm gonna give that a sand and hopefully not go through, because there is, if you see, look, there is an aluminium, just like on the actual bearing itself, there's an aluminium coating on top of a steel back, and if I sand off too much, then it's just going to be running on steel, and if I sand off half of it, then over time it's going to wear and be running on steel, which doesn't sound so good to me. Got my favourite bit of glass for this sort of job. Need a flat surface. I've got some 800 and then some 1200 to finish it off. And a little bowl of water with a tiny bit of soap in it, and I'm just gonna sand it. You can see the material that's come off already. And the idea is you want the thrust backwards and forwards of the cam to be between 1/1000th and 2/1000th of an inch. So not very much. Going on to the 1200 now. I'm pretty sure that's going to be nowhere near enough. Well, it's gone on now. It's a very tight fit, but that didn't take much at all, did it? So we'll give it another go. And the tricky thing is obviously whatever I do to this side, I have to do to the other side. Still a very, very tight fit. Now you can see where I've forced it on, there's some scratches in the surface of the bearing on that side, so that's a good indication. Once those scratches go, then we know we're in the ballpark. So back to the 800. There was 3 scratches, and now there is 1 and a bit. So I'm just going to the other side of it. Right, that now slips on. So what we're going to do is pop this in the case and rig up the dial and see where we are. After sanding the double thrust bearing and then fitting the cam to the case, I got the dial indicator out and just quickly had a look, and it became immediately obvious I'd gone too far and taken too much material off, and the thrust tolerance is way beyond 1 200ths of an inch. So I've had to order some more bearings. I can get them here in the UK, same silver line bearings. So we'll have to go through it all again, filing the tab off and then seeing what the fit's like. I've since done a little bit more research, and I found a YouTube video and it was for a different motor, but what the guy was doing was putting the cam in and then just with a gentle taps, just tapping the cam forwards and then backwards, and that just helps seat the cam bearing in the journal and into the case, and then you get more of an accurate reading. So the other bearing on the other crank half has not been touched at all. It's got the tab on it, it's not been sanded or anything, so I'm going to have a go at that and see if that makes any difference. Well, like the other side, that just isn't even attempting to go in. So I'm going to have a go at experimenting and sanding this bearing here. So I think I'm getting close. Just going to fit this dry for now. I've also read that if you put oil on the bearing when you're measuring thrust, the oil takes up some of that thrust, which makes sense, doesn't it? Make sure everything's clean. I'm not sure it shouldn't pop like that. Oh, well, it does turn actually. Doesn't seem to be any movement backwards and forwards, but before I go any further, I will get the micrometer out, the dial indicator out. So I've got my dial indicator set up. I've bolted on a piece of angle iron because my mount is magnetic type. I haven't got the bolt-on type. To be honest, this whole mounting thing, I need to replace it. It's not the best. You have to really tighten it down to make sure it's accurate, but it does work. Don't worry, I have rubber washers underneath the angle line to protect the mating surface, so it's actually raised up. So I finished doing the sanding. I was using vernier calipers going along, just measuring. I measured the distance between the two thrust surfaces on the cam, and there was exactly 28 millimeters all the way around. I mean, precisionally made. I mean, that was pretty impressive to see. And then I noticed when I measured the outside diameter of the two thrust surfaces on the bearing, it was 28.8 millimeters. So I knew I had to lose 0.8 of a millimeter to get close. So I took it down so it was just above, and I fitted it, and it seems to be a tight fit. It does turn freely. It doesn't spin like freely, but it shouldn't, I guess. And I've set up the dial indicator, and when I'm moving it, I'm getting .03 millimeters, which is somewhere between, I'm getting more now, so it's bang on 80, and now 0.04, which is, yeah, somewhere between 1/1000 of an inch 2/1000 of an inch, so that's right. That's roughly where we want to be, between 1/1000 and 2/1000. So I've kind of figured out how to sort these thrust bearings out. There's a lot of work gone into it. I'm obviously ordered another set, so I'm going to have to go through this whole process again because I want to use matching halves. I mean, I tried searching up, can I keep the half I've done and just take another half from the other set, file the tab off, put it in the other engine case and use that. I haven't found anyone talking about mixing sets of cam bearings. I mean, I've heard of people taking double thrust washers from one set and adding them to another set, but then they're still in pairs, so I'm not going to risk it. I've got a new set coming. I'll just do all the work again on the new pair. And what I plan to do is measure the thrust in each case half. Then I'm going to bolt the case together, torque it down to like 12-14 foot-pounds, and then I'm going to measure the thrust with both case halves together just to be sure. But I can't do that until the bearings turn up in about 4 or 5 days. The same bearings, silver line bearings. So pretty happy with that. And now I understand how the process works. It took me one bearing half to figure it out and get it working. Cam gear, I've already had a look at that. That is not cast. So apparently that's what you want. You want, for harmonics, you want cast and then forged, and one deadens the other. And then once I get the crank built up, I will measure backlash. And I hear a lot of things about these straight cut cam gears, that there's loads of backlash, and people are like, oh, it doesn't matter. Well, I mean, what am I going to do if there is backlash? I can't change it for a smaller size. It's one size fits all. So it will be what it is, but I will measure it nonetheless. Some instructions, which I think is on there. Yeah, that's just what's on the website. So that explains. There's gold, plain and silver. Gold is 0 degrees. See, they're slightly offset. I mean, they're not as obvious as that, but it's, so you can either advance by, well, have it 0 or by 2 degrees, 4 degrees, and then you can retard it as well, the same, depending on which way you turn it. So we will fit the gold ones for now. Well, the gold ones are pretty obvious. They're gold passivated. And then we have these ones. And you've got plain or silver. Oh, I see, yeah. So, I mean, these three are plain. Oops. Dropped it. And these three are silver. So if we put them on top of each other, yeah, you can, they look pretty similar. Well, it's very marginal. There you go. You can see that the, if you have a look. So which ones are which? Which are the biggest? So the silver ones, not sure, you can't really sit, they're very difficult to tell, but these are the silver ones. Let's see what the fit on this is like. I hear that these can be a tight fit as well. So obviously, when you're putting the cam gear on, there's only one right way to do it. Obviously it can go on anyway. So that's what it's explaining here. So that's your crank gear, 2 dots. Your cam gear with 1 dot. The 1 dot goes between the 2 dots, and the groove for the oil pump points directly towards that dot. So, I'm bashing the camera around. So that's correct, not correct, correct. So that's what we want in there. Now, as I say, that's a tight fit. And from what I've read, what you want to do is just pass a little bit of sandpaper around the inside I mean, it should be a tight fit, but not that tight. So we're just going to pass a little bit of sandpaper around inside here, just to free that up a little bit. That didn't take much. That's perfect. It doesn't wiggle and it just clicks in nicely. Literally, I just gave that a very little tickle. So we'll pop these gold washers in, and then there's a spring washer and a, don't know what you call these, dome head Allen bolt, don't know what you call them. And when you, obviously I'm not going to put Loctite on because we're going to dial the cam in, check the backlash and all that sort of stuff. And there's a specific torque setting. You can torque them down to 20 foot-pounds, which is quite high, I guess, one of these things. And we'll get into that later. What I've learned with these engines, with these performance engines, is there's lots of building the engine up, stripping it down, building it up and tweaking it, which is a bit of a pain in the arse, to be honest. That's the thing, a lot of these fasteners, like all the oil stuff, these, probably everything else, is going to be US sizes, which makes it easier for the US guys. But you know, if you're building a German engine, surely you should be using metric size stuff. So I'll have to buy a set of Imperial Allen key sockets because I haven't got any to torque these down. So I'm snugging them down. This is just to test the clearance on the oil pump. So here's the oil pump, and we're just going to pop it in. And yes, glad we tested this. See that? That is one of the nuts catching on the back of the fuel pump, of the oil pump rather. This nut here is catching on the back of the pump. I need to clearance these three in order to clearance the oil pump. I've just taken the bolts off and I've noticed that the spring washers that come with the cam, the plating or some sort of coating is just flaking off. So I will replace these with stainless parts. As we've gone to such care and attention on the case and the moving parts, I'm just going to use a knife and just take off the burrs on the filed edge. I've got a teeny tiny set of scales here disguised as a car fob, car keyring fob. I wonder why people would want to hide the fact they're carrying scales which only measure a few grams. 7.68, 7.67, 7.67. So out by 1/100th of a gram. So I've got some feeler gauges in here. I've got 0.008, 0.012, which adds up to 2/100ths of an inch. But that's probably going to be enough, what with the gasket as well. I will look it up. I've just been in and to do a little bit of research, and it looks to me like what a lot of guys do is they just take out the spring washer and put Loctite on, which I was going to do anyway, and then that's going to give me a whole bunch of clearance and it won't be an issue or a worry. And as the plating's coming off of these washers anyway, I'm going to take them out and chuck them away. After taking out the spring washers with the flaky coating, I don't even need feeler gauges now. It's literally, I can see we have about 2 mil clearance, and then you've got to imagine there's a gasket as well, which is probably like 1/100th of an inch. I mean, not that that's going to make much difference, but there is loads of room. So that's that done. I'll put this away. I was also reading online that some guys clearance the back of the oil pump, but I wouldn't want to touch that. After sanding too much off the double thrust cam bearings I originally got from CB Performance, I bought another set exactly the same as they supply. So I'll open these up, take out the two thrust bearings. First thing to do is to sand off the tab on one of them, and I'll do that now. In my many hours of researching this whole double thrust cam situation, I saw a guy that taped the two halves together, and I thought that was a nice idea just to start them off, just to make sure you're taking the same amount of material from both. Takes a bit of the guesswork out, and hopefully it will hold it a little bit flatter as I sand it. So as I did before, I'm just going to use my favourite piece of glass, some 1200 grit wet and dry paper, get it a little bit wet, and I'm just going to take some of the material off. As I go, I'm going to be measuring it with vernier calipers just to see how much I'm taking off each round. Hopefully I won't take off so much that the thrust is too much this time. I'm going to measure the amount of thrust it has. This dial indicator is not an imperial one, it's metric. 0.025 millimeters, which is exactly 1/1000th of an inch. So through sanding it, we've got it to the right place on this half. So that's one half within spec. I'm now going to put the cam in the other half, measure the other half, and we'll see if that's in spec too. I sanded them both together using that tape method, which has worked really well. When I did the other set, which I messed up, I was doing them individually, and I noticed that it was getting thinner quicker on these edges as opposed to the middle here, so it wasn't sanding evenly. So by putting them together and taping them together, even though it's not 100% accurate, it's helping push the load around the whole surface rather than just on those edges. So that's a good tip if you're ever going to do this, is tape them together. So thanks to the guy, I can't remember who it was, who posted that up on YouTube. That's a good little tip. So let's get the other case half in the engine stand, and we'll measure up the thrust on the cam in that half. So this is the other case half, pushing the cam, looking at the dial. .025 again. So it's starting there and ending there. So far so good, but that's not the end of it. Next thing I'm going to do, just to be doubly sure, I am going to bolt the two case halves together, and then I'm going to remeasure the thrust with the two halves together, because obviously once the bearings are crushed down together and they're seated, both thrust surfaces on the thrust surfaces of the cam, that tolerance might change, it might go down, it might be too tight. So I just want to double check that. I'll put the two case halves together, I'll just snug them down, I'm not going to torque them or anything crazy like that, and we'll see what happens. Both halves of the crankcase together, dial indicator on the back of the cam there. I'm just going to push the cam in and see what we get. So it's the same, 0.025 millimeters, 1/1000th of an inch, which is perfect. Well, it took an extra set of bearings at a cost of about £18, but the cam thrust is dialed in perfectly to the minimum tolerance of 1/1000th of an inch. So super happy with that. Now I'm going to, even though my crank isn't fully built, I have the cam gear on the crank, and that's the only gear I have on there. I'm going to have a look at backlash on these straight cut gears, and from what I've read online, it's not going to be great. It's probably going to be outside VW tolerances, but there's not a lot you can do about it. You can't buy different sized cam gears that are straight cut, so you just have to go with what you've given. So unless it's wildly out Just gonna have to run it as it is. Got the crank in, it's all seated down, the lines on the bearings are all aligned, dowel pins in place. I've checked the other half of the middle bearing, no movement there, so that's all nicely aligned. Now I'll get the cam gear and let's find the marks on. I'm looking for the 2 dots. There's the 2 dots on the crank cam gear. And where's the dot here? So we put the dot in the middle, those 2 dots, that tooth, and then we roll it around those gears until it wants to find its home. And then just to double check that those still align, and they still align. And then let's just do a rough test. So I'm going to put my hand on the crank. I've never done this before. Hand on the crank just to hold it in place, and then move the cam backwards and forwards. You can hear that clicking, listen. That's the backlash. So what we need to do now is rig up a dial indicator on one of these teeth. I'm going to try and align the peg of the dial indicator so it's as much as a tangent off of this as possible to get a true reading, and then I'll move that backwards and forwards and we'll see that if that's within spec. It's not too bad. Got the dial indicator rigged up on one of the cam gear teeth. I've got it as much of a tangent as I can get it, but to be quite honest, it's kind of tipped in a bit, so not really all that accurate. And when I'm moving it backwards and forwards, we're getting a reading of 0.05 millimeters. Now that is a little bit less than 2/1000th of an inch, which is within tolerance. VW suggested from 0 to 2/1000th of an inch. So the first time we've done something on this engine so far where it's worked out well. I haven't had to make any adjustments, not that I could make any adjustments on this, so I'm a little bit relieved that it's within tolerance. So the thrust backwards and forwards, the end play on the cam shaft is good, perfect, and the backlash is within tolerance. I mean, it's on, I think it's like 0.0196. I just looked it up, thousandths of an inch, and that is right on the edge of very close to 2/1000ths. So, but it's within the tolerance, so good. What I'm going to do now is just swivel my dial indicator out the way, and I'm going to turn the crank backwards and see if the camshaft lifts out of its bearings, which would indicate that the backlash is too tight, the cam wheel's too big for the cam gear on the crank. And we know the backlash, we've measured it, so we know it's not going to do that, but you know, let's just do that anyway. And that's turning great. So happiness, happy days. Well, I'm pretty happy with the way it's worked out. The backlash is good. Well, actually, it's just about within VW recommended tolerances, which is great for an aftermarket straight cut cam gear. I've heard horror stories about some of them being like 8 to 9/1000ths of an inch, which would be really noisy, loads of scatter in your idle, I would imagine. So I've lucked out there that it just happens to fit with the case that I've got, and it's all great. I've dialed in the thrust of the camshaft, and that's right on spec. I'm very happy with that. So all in all, a successful progress for the engine. Thanks for watching. Catch me soon.